Okay, on the last video, I promised some discussion about architecture. So I thought I'd talk about how I got this whole thing started with the ammonia molecule and running out of memory and all sorts of stuff like that to drive a better framework so that I can handle different molecules and structure it so that I can learn all the way up to these really large molecules which are involved in nitrogenase. Nitrogenase, do you know what that is? Well, let's not even talk about that right now. Let's just talk about how we want to analyze a bunch of molecules and the quantum chemistry that goes along with it. So, if you notice on the screen, I have a series of folders under Qiskit projects. Qiskit projects is, well, that's the form of software that is simulating the quantum computer. And it's also the software that can talk directly to the computer. And you'll notice down here I've got .vs code. What's in there? Launch JSON settings.json. So this is just for organizing the VS code itself and figuring out how it starts up when it runs a program. Very non-interesting. Then we find out that these things have to run in what's called virtual environments. So if we open this thing up, there's all the different environments that I've used. And right now, the one I'm using is QC Research PY312. That's Python version 3.12. And these are all the other ones. But that's a very complicated part of this whole mess, is that you have to have different packages that the system requires, but not the same ones that are on the standard setup. So you create this virtual environment and it operates in this setup. That's not too informative, but it's what I have to go through. So let's close up the virtual environments. And let's look at the legacy NH3 scripts. Here we have a complete program in one Python file. Everything that it does is in one Python file, which you might think, well, that's nice, but it's not very flexible. What if you have to switch away from NH3 and want to use a different molecule? Well, that's not very easy. So the next transition was I go to this thing called a project, and it has various folders. Here's the main that actually runs the program. And then let's see if these folders are populated at all. Dataset builder, profiling, scaling metrics. See what's in the core. Hamiltonian builder. Let's see, I don't see a molecule builder. Perhaps that's somewhere else here. There's the mapping that goes on. And maybe it's in PYSVS, that Python self-contained field interface. Let's go down through here. It's getting a little bit boring. Here's the experiments. You have different experiment types, but it's not broken up too much. There's logging config. Are you still with me? You might not be, because this isn't that interesting, but it is to me, so that's why I make the video. So let me close down the project and let's go to some of the really good stuff now. And it shows I'm serious because my main folder is Quantum Chemistry Research. And if we open that thing up, we'll find out that we have, we don't even have the main. Where does the main go? Well, everything that I'm working on now is in the source code. This is where all the Python stuff lives. There's the main you can see down there. But what happened before that? Well, what happened before that, I shoved into archive. And the archive had one version of this framework type of stuff. You notice it's fairly compact, core, execution, all these different things, and it's got different molecules that are supported. It's even got a special folder for the menu system, which that helps because the menu is starting to get very complicated because we have to give the user all kinds of choices. So let me keep going on here. And all of that stuff was put away and under version control. So what are we doing now? Well, what we're doing now is this stuff. Here's all the source code. And look at all these different folders. Electronic structure, execution, experiments, Hamiltonian, legacy reference source. What's in the legacy reference source? Okay, it's got some using the Hamiltonian builder as a working reference. So you'll find out that this source code isn't actually even executed, but it's there to help me understand stuff and build up my new stuff. So what's in place of the Hamiltonian? Well, let's see what's in there. Ooh, fermionic Hamiltonian, qubit Hamiltonian. So it breaks it down into finer little pieces. All of these pieces are in the vertical slice that goes through all these things so I can get a handle on all that. Let's see, what do we got? We got molecules. Oh, instead of a molecule building, we have a geometry builder. Here's the data for the molecules. This takes that information and creates geometric. That's not the best way of saying it, but it creates the geometry that we need to move on. And solvers, I think we had some, here's the exact solver, so I have exact solvers working now, so I'm moving along pretty well. And let's see what the user interface looks like. Is that more complicated? It's still just got menu.py, so that's all we got. Let's take a look at, let's see if I'll reduce my image here so we can look at stuff. Let's bring that down to a reasonable size. Whoa, how about just off the screen altogether? Okay, we don't really need to see my face. So let's look at main.py and see what that looks like. Is that main.py? Oh, yeah, it is. Okay, that looks like a menu. That looks like the menu. Wait a minute. I know what's happening. Let's look at main. Okay, here's main. Notice how short it is? And it has, we create this experiment. Let's look at the experiment. See, it's got all these different pieces in that class that we can use. And then we go down into this stuff where we have a molecular energy type. Here's the molecule. Here's the basis type. Here's the experiment mapper. Here's exact. And then we go to the menu. And then we go down, look at these. Oh, look how nicely everything is set up here. These are the things that execute one right after the other. Build the molecule model. Calculate the electronic structure, build the Hamiltonian, map the qubits, and then finally you do the solving. Then you print the energy. Now that's really nice and contained, and what I'm working towards is having a way to save all the configuration items each time so when I go back to it, it remembers all the choices that I made. That's about it for this video. So I hope it helped you as much as it helped me look at what I'm doing.